Hello everyone, myself Jayaditya. I am pursuing BTech second year in VVIT. Today's topic is Understanding Zener Diode Breakdown Mechanisms and Applications and Their Usage. Introduction to Zener Diode. Zener Diode are the special type of semiconductor diodes are designed to operate in reverse bias breakdown voltage. Unlike standard diodes like that are typically damage the reverse breakdown voltage, Zener Diode are the engineered to withstand their conditions to maintain a stable voltages across their terminals. This makes characteristics makes them invaluable to various voltages, regulator, protection, and their circuits. Genodiode characteristics. Genodiode characteristics. Voltage regulator. It maintains the stable voltage output. Various applications used in devices, electronic circuits, reverse breakdown. Core functions of genodiode. Protection circuits protects against overload. These are helps in various cases. Gina diode characteristics. Gina diode distribute Gina diode for others as symbols and etc. Enable breakdown at low voltages, narrow deflection region. In Gina diode at the narrow deflection region enables the low voltage and creates breakdown. Creates narrow deflection region, heavy doping region at the genodiode. Genodiode structure and the symbols. A genodiode is a heavily doped p-n junction diode that heavily doping results in a narrow deflection region. The symbol of genodiode is similar to the standard diode, but the bent end of the cathode bar distribution in for a regular diode. It means if you see genodiode and the regular diode, both are same, but the difference is at the cathode, the genodiode and two ends are some bent. Breakdown mechanisms. Two in genodiode there are two types of breakdown mechanisms. Two primary breakdown mechanisms can occur in reverse bias conditions. Which breakdown mechanisms occurs in reverse bias diodes? Genodiode and avalanche breakdown. Zener breakdown occurs at low reverse voltage characteristics by turning off a charge carriers. Avalanche breakdown occurs at various high reverse voltages involving multiple of charge carriers through collisions. Zener diode occur at low reverse voltage and avalanche breakdown occurs at a high voltage. Zener breakdown. The Zener breakdown mechanism. Zener breakdown occurs in heavily doped p-n junctions with a narrow deflection region. The strong electric field is the deflection region can directly break covalent bonds, generate electric hole space, their carriers and the acceleration by the electric field resulting in a large reverse current. Voltage dependence. Zener diode breakdown typically occurs at a low reverse voltage below 5 volts. Below 5 volts. The breakdown voltage is highly dependent on the doping concentration. Highly doping leads to the low breakdown voltage. Temperature coefficients. Zener breakdown has a negative temperature coefficient as temperature increases, Zener voltage decreases. If you see here, when temperature is increased in Zener diode, then Zener voltage is decreases slightly, very small change. Zener breakdown mechanisms. There are dependent voltage dependence, electric field dependence, temperature coefficients, electron hole pairs, Zener breakdown. Voltage dependence. Lower voltage due to doping ping at the low doping region. Electric field breaks covalent bond into deflection region in very small parts. At temperature coefficients. At negative temperature, effects on Zener voltage. Electron hole pairs generate carriers and accelerate the current through the Zener diode. Zener breakdown. Core mechanisms of diode failures. Avalanche breakdown mechanisms. Avalanche breakdown occurs in lightly doped p-n junction diode. Lightly doped p-n junction diode. If you see, further, Zener breakdown occurs at heavily doped p-n junction diode and avalanche breakdown occurs at lightly breakdown from p-n junction diode with a widely deflection layer with a small deflection layer. When reverse voltage is applied, minority carriers gains kinetic energy and the acceleration toward the deflection layer. here. If the voltage is high enough, this carriers collides and atoms in crystal lattice. When voltage is high in avalanche breakdown, the crystal lattice present in the atoms, both the atoms are collides and makes a creative new electric hole pairs. This newly generate carriers also accelerate and collide with other atoms, creating an avalanche effect to rapidly increasing current by increasing the current. Voltage dependency. Avalanche breakdown typically occurs at a high reverse voltage, but Zener breakdown occurs at low reverse voltage also, typically above the 5 volts. Zener diode is below the 5 volts and avalanche breakdown is above the 5 volts. Temperature coefficients. Avalanche breakdown has a positive temperature coefficients. As temperature increases, the breakdown voltage increases slightly. If you see for in case as in Zener breakdown, temperature increases, Zener voltage decreases slightly, but avalanche breakdown temperature increases, the breakdown voltage increases slightly, very small change. Avalanche breakdown process is stable diode carrier acceleration impact ionization avalanche effect breakdown down diodes. In stable diode no current is flow. In carrier acceleration, minority carriers gain energy and go and collide with another carrier atoms. Impact of ionization. Carrier collides create a pairs. By creating the collidation, new bonds are formed and new atoms are formed. Avalanche effect. By colliding rapidly, the current is increasing on avalanche breakdown voltage. High reverse voltage current is produced. Both G Note, both Zener and avalanche breakdown occurs at Zener diode, but the Zener effect dominates at a low voltage while the avalanche breakdown becomes more significant at high voltages. Diode designed to operate at voltages around 5 volts around 5 volts only exhibits a combination of both effects. Zener breakdown effect. Zener breakdown characteristic. Combination of effects occurs around only 5 volts. Avalanche breakdown. Combination at high voltages. Zener breakdown dominates at low voltages. Avalanche breakdown dominates at high voltages and Zener breakdown dominates at low voltages. Reverse breakdown voltage is denoted by VZ. This is the key parenthesis of a Zener diode. It is the special characteristics of a special reverse voltage at which the diode begins to conduct significant in the reverse direction. Zener impedance, it is denoted by ZZ. This is the dynamic resistance. Dynamic resistance RF of the reverse diode in the breakdown region. It represents the change in voltage of a given current. A low Zener impedance indicates a more stable voltage regulator. When low Zener impedance is occurs, then more stable in voltage regulation. Maximum power dissipation. This is the maximum power that the Zener diode can safely dissipate without being any damage. It is determined by the diode voltage and current rating. On here, the Zener diode effect is very much and very safe. On increasing vary current, the Zener diode controls the current and voltage of the power and pushes how much amount of power they want to the circuit. Temperature coefficient. As mentioned earlier, Zener diode has temperature coefficient that indicates low Zener voltage change with temperatures. Zener diode parenthesis. Temperature coefficients. Influence of temperature of voltages. Maximum power dissipation. Safely limited for diode operations. Zener impedance. Stability indicates in breakdown region. Zener breakdown voltage. Core parenthesis for the diode operation. Advantages of Zener diode. Simply and inexpensive. Zener diode are relatively simple and inexpensive component. Stable voltage regulator. They provide a stable voltage regulator over a wide range of outputs and voltages, load currents variations. Fast response time. And Zener diode has a fast response time making them suitable for applications requiring quick voltage jumping, etc. Disadvantages of Zener diode. Limited power handling. Zener diode has limited power handling capability, like some voltages below 5 voltages, but in above 5 volt, but above voltages like higher voltages, the Zener diode will be break and damages. Temperature sensitive. The Zener diode is temperature dependent, which can affect the accuracy of voltage regulator. When we increasing the temperature, when we increasing the voltage, the power is dissipated. By the power dissipation, the temperature increases. So Zener diode cannot withstand in high temperature. Zener impedance. The Zener impedance can cause voltage variation with the change in current. When the current is changing, when the current is changing very quickly and very fast, then the Zener voltage impedance is occurs to control overcome the change of current. Conclusion. When Zener diodes are essential components in mainly electronic circuits, provide a simple and effective way to regulate voltage and protect sensitive components for over voltages conditions, like when we give the high currents and high voltages, the Zener diode doesn't satisfy when like this, when Zener voltages couldn't take high voltages and it becomes breakdown. Understanding their breakdown mechanisms, characteristics, and applications is crucial of design and reliable and effective electronic systems. While they have limited their advantages of their outweigh the drawbacks, making them a valuable tools for electronic engineering and hobbies. So like, for example, breakdown mechanisms. Zener and Avalanche breakdown mechanisms explained characteristics. Key electrical characteristics of the Zener diode applications used to voltage regulator and over voltage protections, advantages, disadvantages. Advantages like simply effective and reliable voltage regulations. Disadvantages like limitations including temperature sensitive and power dissipation. This is helpful in many ways in the study. Thank you for watching.